Yes, students. So now we are going to start the next property of the solids when a deforming force is being applied on that solid body, and the other property of the solid body is strain. So now we will discuss about strain. Okay, students. So as in case of a stress, we had discussed that in case of a stress we had discussed when a normal force or perpendicular force to the cross sectional area of a body is applied, then the stress is produced, and a stress is of different types, that is normal stress we had discussed, tensile, compressive stress we had discussed about shear stress, bulk stress, hydraulic or volumetric stress we had discussed. Now when deforming force acts on a body, the body undergoes change in its configuration or change in its shape. So on application of deforming force, the body change its shape. So relative change in configuration of the body is called strain. So how can we define a strain? In simple language we can define a strain that it is the ratio of change in configuration to the original configuration. Change in configuration. So strain can be said that strain is equal to change in configuration upon original strain is change in configuration of the body with original configuration. So the changes which are taking place when the deforming force is applied on the body, the changes which are taking place, that changes are either in the length of the solid body or in its shape or size. Whatever the changes we are going to observe, so the change upon original change is called as strain. Now on the basis of different type of stress, as we had studied about different type of stress, so on the basis of different type of stress we may classify a strain also on the basis of a stress applied on the body. So the first one is longitudinal strain. Longitudinal strain. And longitudinal strain is due to the normal stress or longitudinal stress. It is the effect of longitudinal stress, and longitudinal strain can be written as strain can be written as change in length upon original length. It can be written as change in length upon original change in length upon original length. Now dear students, look at here. Since it is the ratio of two similar quantities, so it has no unit and no dimension. It has no unit and no dimension. Now the second type of strain is volumetric strain. Volumetric strain. And volumetric strain is the result of, or is the effect of bulk stress oblique hydraulic stress. It is the effect of bulk stress or hydraulic stress, and in this type of stress, as I had told you, the shape and size of the object is changed. The shape and size of the object does not changes, but its volume changes, and as its volume changes, so volumetric strain can be written as volumetric strain. You can write it as delta L upon L. Volumetric strain can be written as change in volume upon original volume. Here I am drawing the diagram for, suppose this is length L and it had changed to length delta L. So delta L upon L. Similarly, if there is a solid body and you had applied a hydraulic or bulk stress on the body from different directions, and if the initial volume of the body is V, due to the application of different directions of bulk forces or bulk stress, the volume changes to delta V, and this will become V minus delta V, means volume is going to be changed. So change whatever the deformation had taken place, delta V upon V, so it can be written as delta V upon V. So this is about the volumetric strain. Now we will discuss about shear strain. The third one is shear strain, and as this is the result of shear stress, shear strain is the result of shear stress. So here we consider the tangential force. Here we consider about the tangential force. The third one is shear. The third one is shear strain. And as we are talking about the shear strain, so whatever the forces acting on the body, the forces are of tangential nature, and since the forces are of tangential nature, so what will happen? As in case of shear stress, we had discussed that the upper part of the solid is going to shifted relative to its lower part, which is fixed part. Lower part is the fixed part, and due to the tangential force F, the upper part of the body is going to shifted by an angle of theta, relative to its lower part, which is the fixed part. So this angle will be theta. So shear strain shear strain, if it has length L, suppose this is the cube of length L, it is a cube of length L, so the length changes by delta L. Due to shear stress, the length changes by delta L. Now look at here, a triangle is formed. Just like this, a triangle is formed. This is theta, this is L, and this is delta L. So shear strain can be given as tan theta, shear strain, and this angle theta is called as what? Angle of shear. Angle of this is called, theta is called as angle of shear, and tan theta can be written as delta L upon L. Tan theta can be written as delta L upon L. And if this is tan theta is called as shear strain. Tan theta is called as shear strain, and it is equal to delta L upon L. For a small angle of theta, for a small angle of theta, tan theta is approximately equal to theta, so theta can be written as delta L upon L. Theta can be written as delta L upon L, and this theta is called as shear strain. For if unit length, if the cube is of unit length, if cube is of unit length, if cube is of unit length, then L is equal to 1, and then tan theta is equal to delta L, or shear strain can be said that shear strain is equal to delta L. Shear strain that is equal to delta L. This shear strain is equal to delta L. Now, dear students, this is all about the two mechanical properties of solids, that is stress and strain. Now we are going to discuss about the Hooke's law. Hooke's law. From here you have to study in the syllabus. Rest of things what I had taught is just for your basic knowledge. Now we will discuss about Hooke's law. Hooke's law, in the year 1679, in the year 1679, the famous English physicist Sir Robert Hooke and he had performed the experiment on various type of rigid body. He had taken various type of rigid bodies, and on that rigid bodies he had applied different type of forces, he had applied, and that forces are said to be load, and he had observed that when load on that rigid body is being increased, due to that load the extension is produced in the rigid body. And after experimental observation, he had put forward a law, and the law said that extension is directly proportional to load. Extension produced in the rigid body, it is directly proportional to the load applied. It is directly proportional to the load applied. Whatever extension produced in the rigid body, that extension produced in the rigid body is directly proportional to what? Load applied. But when this law goes in public domain, various views had came regarding this law, and now this law is made generalized, and the generalized version of this law says that any type of deforming force is applied on the body. Any type of deforming force means twisting, compressing and bending. Any type of deforming force when applied on the body, then any type of deforming force applied on the body, that is twisting, compression, bending, etc. Any type of deforming force is applied on the body, this law holds good. This law, whatever the law given by Robert Hooke, this law holds good for any type of deforming force. So if there is a deforming force, then for the deforming force we had studied there is a stress in the body. So the law is modified, and it had given that the new law was pronounced, and it was what? It was that within elastic limit, stress is because stress is the result of deforming force. So stress is, and deforming force is the load, and extension, so produced extension is the result of strain. So within the elastic limit, stress is directly proportional to strain. Stress is directly proportional to strain. So this was the Hooke's law. Now we can write this like that. We can write this statement in this way. Within the elastic limit, stress is directly proportional to strain. And from here, if we remove the proportionality sign of proportion by a constant, then it can be said that stress is equal to E into strain. And then we can say that stress upon strain is equal to E, and E is what? E is called as modulus of elasticity or coefficient of elasticity. Modulus of elasticity or coefficient of elasticity. Okay. Yes, students. So this is about the Hooke's law. Now we will clarify much more about the Hooke's law by taking an example, and I am taking a wire, and on that wire we are going to apply a load, and subsequently we are going to increase the load over the wire, and as we are going to increase the load over the wire, the extension produced in the wire also increased. So we are going to study about a curve that is called as a stress strain curve, which shows the characteristic of variation of stress with strain. So look at the next heading, that is stress strain curve. stress strain curve. Stress strain curve. Now look at the stress strain curve. Suppose we had taken a rigid body. And over this rigid body we had applied a load. Force. Clear? And as we had applied the load, since this load is in the downward direction, so this is the load which elongates. This, due to this load, the wire is going to be elongated. So if it is L, then it becomes delta L. Now look at the graph, what we are getting. This graph is called as a stress strain curve. So strain and stress. Stress is what? Force per unit area. Stress is force per unit area, means as we are going to increase the force or load over this wire, as we are going to increase the load or force over the wire, the elongation produced or elongation in the wire is going to be increased. So if I am saying stress is directly proportional to strain according to Hooke's law, so within the elastic limit up to point A, suppose at up to point A, the body obeys the Hooke's law, and after that also for a certain value, that is point B, that is called elastic limit or yield point. Point B is called as elastic limit or yield point. The body up to this position, the body is compelled to obey the Hooke's law because this is the elastic limit. Now after that, if we are going to increase the force then or load, then the body will not obey the Hooke's law and we will reach at the point C. And at point C we will get permanent deformation in the body. Body gets permanent deformed. Suppose this is O point, then after removal of the force at this point we will reach O dash, that is permanent deformation. O dash is the permanent deformation in the body. Now if further we are going to increase the load, then we will reach a point, that point is called as D, and this point, so this A is called as, or I am writing here, OA is called as proportional limit. OB is yield point or elastic limit. Yield point or elastic limit. O dash permanent deformation. Permanent deformation, body is permanently going to be deformed. And at point D, if further we are going to increase, so at point D it is the fracture point. This point is called as fracture point, and at this point the body gets breakdown, the body breaks. So this point is called as fracture point. So this is the about the elastic, because up to point B we will observe the elastic behavior. Up to point B we will observe the elastic behavior of the material. Elastic behavior and beyond point B we will observe plastic behavior. We will observe plastic behavior of that rigid body. So this is the characteristic curve or stress strain curve for the variation of a strain, the strain produced in the body. Okay students, this is about the stress strain curve. Now on the basis of stress strain curve, we will classify the materials among different categories, that is ductile material, brittle material, malleable material. So look at here. Classification of material on the basis of a stress strain curve. Classification of material on the basis of stress strain curve. Classification of material on the basis of a stress strain curve. So first one is ductile material. Ductile material. And what is the property of ductility of a body? Property of ductility of a body is that it can be elongated in a thin wire. It can be elongated. It can be shaped into thin wire. It can be shaped into thin wire. And which material can be shaped into thin wire? That material whose elasticity is more, or that material whose fracture point is larger. Whose fracture point is more. Means if just you are going to elongate that body just like glass. So if in case of glass, if a certain deforming force is applied, just after applying certain moment it can be break down. So it cannot be taken as a brittle material. So brittle material are that which can be shaped into thin wires, and for the stress strain curve for the brittle material, stress and strain for the brittle material, the gap between point C and point D, CD will be larger region. This region will be larger for ductile material. Second one material is brittle material. Brittle material, just like glass, just after applying the force beyond the elastic limit going to be breakdown. So that is the brittle material. Brittle material. It can be breakdown just after applying the force beyond elastic limit. And for brittle material, the gap or spacing between point C and point D is very less. CD very a smaller region. The region for CD is very small. For brittle material, and the next category is malleable materials. Malleable materials are those materials, malleable materials, or the property of malleability is that which can be compressed into thin sheets, malleable materials that can be compressed into thin sheets, and the here applied force and compression, and this is point C and point D, and this point D is called as crushing point. Beyond, if it is compressed, then it will break down. So this point is crushing point. So here also, for making a material into thin sheets, the distance between C and D must be larger. CD, larger region. This is about the malleable materials. So this type of materials can be crushed, they are compressed into thin sheets, and this is called as the crushing point. Gold, silver, lead, examples are gold, silver, lead, etc. These are the examples of malleable materials. Now there is one thing that is called as elastomers. What are elastomers? Elastomers are that materials which have not their well-defined elastic limit. Elastomers are that materials which have not their well-defined elastic limits, and up to a large range they cannot follow the Hooke's law. So elastomers, the materials which does not have any well-defined elastic limit, and they can not obey Hooke's law for a large range. And the stress strain curve for elastomers is just like that. For example, rubber. Example is rubber. This is stress and this is strain. Stress and strain. As students, you are knowing that in case of rubber, For initial stage, when you are applying the force, the elongation will be large, but when they are getting elongated, after that, if the same amount of force is applied on that rubber, the elongation will be not proportional to that which initially you had applied. So that is called as elastomers, and rubber is not obeying the Hooke's law for a large range. So they are the various examples of elastomers are aorta of blood vessels or arteries, which in the blood vessels there are arteries and veins. They are also elastomers. They also does not obey Hooke's law for a large range. So that's all for this video, students. Now in the next video we will discuss about elastic modulus, various type of elastic modulus, and certain remaining things we will discuss. Thank you, students. Have a nice day.